Hi, welcome everyone. Today we are excited to be presenting our findings on carbon, cancer, and contamination, the relationships between pollution, temperature, and disease. Here's
Hi, I'm Isabella Huang, class of 2023, and I'm from New Jersey.
Hi, I'm Sydney Bramen. I'm the class of 2022 from Pennsylvania.
Hi, I'm Joanna, class of 2022 from California.
Hi, I'm Emily, class of 2023 from New York. Here's an overview of what we'll be walking you through today. We'll start with goals and introduce our data, lead into results, and finally wrap up by talking about our conclusions and limitations. With the growing threat of climate change to today's world, we decided to study the impact of environmental changes on U.S. lung cancer rates. Our goal was to explore the relationships on both the country and state level and come up with a final equation that models the lung cancer incidence rate per 100,000 people.
This is our data and our first exploratory data analysis. We began by first exploring all types of cancer in a dataset found from the World Health Organization and their death rates over a course of 4 different years. When we plotted the cancer death rate per 100,000 people by year, we found that lung cancer was the leading cause of cancer death. Lung cancer is shown to have a slight downward slope, which could be from the increased awareness of hazards of smoking. The majority of other types of cancer that we researched are shown to have much lower death rates and have maintained a constant rate over the given period of time.
Next, we performed an exploratory data analysis on air pollution. When investigating air pollution levels, we decided to focus mainly on carbon dioxide, as it's one of the main greenhouse gases emitted through human activities. The dataset we decided to use was from the World Bank and described the amount of CO2 emissions in metric tons per capita from the years 1961 to 2019 in only the US. It should be noted that the data only accounts for production and territorial emissions, like CO2 emissions from cement production, but doesn't consider the emissions of traded goods and consumption-based emissions, like personal choices in pre-purchase transportation. To begin our analysis, we plotted the data on scatter plots. We saw that there was a large spike from the 1960s to mid-1970s, then afterwards a general downward trend. We figured the decrease in pollutants in recent years may be because of the increased awareness regarding global warming and attempts to help air pollution with electric cars, renewable energy, recycling, cutting down on plastic, and other forms of environmental conservation. If you look at the graph, you can see that the y-axis doesn't start at 0 emissions. So while there is a decrease in emissions in recent years, emissions are still very high. Additionally, the CO2 emissions in our data set don't account for emissions that might be from personal transportation, wholesale, and other carbon-emitted goods and services that are determined by the choice of an individual, which means that even though production and territorial CO2 emissions are going down, overall CO2 emissions may not be. Our final country-level exploratory data analysis was regarding temperature change. The dataset we used was from Food and Agriculture Organization and described the average degree change from year to year in degrees Celsius by month. For example, when the data recorded negative 0.1 degrees Celsius for January 2010, it meant that there was a 0.1 degree decrease in temperature from January 2009 to January 2010. By plotting each month on a line plot, we saw that there is an overall increase in average temperature change since 1960s.
In our investigation of country-level data, we found that lung cancer had significantly higher death rates per 100,000 people compared to other cancers, so we decided to gather data on the state level to study the effects on a smaller scale. These datasets came from a combination of U.S. Energy Information and Administration and national academics. This heat map illustrates the age-adjusted lung cancer rates for each U.S. state, which means that age is no longer a variable in exploring lung cancer rates. The darker the blue, the higher rate of lung cancer there is in that state. From this heat map, it is evident that U.S. regions in the North and Mid-South have higher rates of lung cancer compared to the western part of the United States. To control for other factors in further researching lung cancer at a state level, we considered the factors smoking, gender, alcohol consumption, air quality, average temperature, and region. Then we explored these variables on heat maps to see similarities between them. In particular, the smoking rates are the highest in Kentucky, which could be correlated to Kentucky's high rate of death for lung cancer. However, in states like New Mexico, which have very low carbon dioxide emissions and smoking rates, the lung cancer rate could be much lower than rates in Kentucky.
And these are our results. Next, we performed a regression using the ANOVA function on temperature change and carbon dioxide emissions, where we found that emissions positively affected the increase in temperature among the years. The graphs on the right show that our regression has normality, homeostasticity, and linearity, except for some irregularities like the QQ plot tail. Finally, the significance codes at the bottom show how the relationship between CO2 emissions and temperature change is in fact significant at the 0.001 level.
When looking at all the variables we analyzed, since we took into account multiple variables, we decided to perform a type of linear regression called lasso, which shrinks the data values towards the mean and helps reduce the variances within our machine learning model. After performing the training, final fit regression, and backward selection, we found that out of all of our total variables, 8 were significant. Some variables like smoking, being older, or living in Kentucky or Rhode Island increased the death rate of lung cancer, while other variables like being male, living in Arizona or Wyoming decreased the death rate of lung cancer. Note that the state variables were all in reference to Arizona's conditions. To the right of the slide are images of assumptions we checked. Through looking at the QQ and residual plot, we see that the linearity and homostochasticity all appear to be good as there's randomness and normality. On this slide is our final model equation, which consists of the 8 significant variables to predict lung cancer rates per 100,000 people. So some of the possible sources of error when we performed our final lasso model and produced the equation include healthcare systems, laws for carbon dioxide emissions, which could decrease emissions in certain areas, and income, which could lead to increased lung cancer death rates if an individual doesn't have the necessary resources surrounding them.
Finally, as in any analysis or study, there's always the likelihood of bias or error, posing limitations to our work. For instance, we did not consider advances in medicine or changes in some important trends, or the accuracy of our collected data could be incorrect. This might have slightly altered our analysis and conclusions. And now we want to give a special thanks to the Wharton Data Science Academy, which helped us gain the knowledge and experience to be able to complete this project. We would also like to thank Linda Zhao, our incredible professor at the Academy, and Shannon Duncan, our teaching fellow. Thank you for listening.
Hey everyone, I'm Sally Hu, and today I'll be presenting on the impact of socioeconomic status on career choice and advancement. So the motivation behind this research is that in the United States, there's a widely embraced idea of lifting yourself up by your bootstraps, that if you believe it, you can achieve it. However, this idea ignores the advantages and disadvantages that an individual can't control, such as race, gender, age, all of those factors. So the goal of this research today is to pinpoint the impact of socioeconomic status on advancement, namely the mobility between income classes based on actual monetary income, as well as the alignment between expectations and educational attainment, which we'll go into in a bit. So for this study, we used the baccalaureate and beyond longitudinal study from the National Center for Education Statistics. And this study examines students' education and work experiences after they complete a bachelor's degree in the United States. Now, what makes this data set particularly unique is that it uses a nationally representative sample of post-secondary students and institutions, as well as a longitudinal design. So it follows graduates for 1, 4, and 10 years after completion of their undergrad. What's even more unique is that the same study was conducted for 2 decades, so from 1993 to 2003, as well as 2008 to 2018. So there are a ton of variables in this data set, but those that were relevant for this study included indicators of demographics, socioeconomic background, education, as well as career measures. And for this particular analysis, we also used 3 models. That includes logistic regression, random forest, light gradient boosting machine, and you'll see that random forest performed the best out of all of them. So the first question that we're trying to answer here is, how do individuals move between income classes? And this is defined as coming from your family income class, moving into your individual income class. Although the gender gap persists, it has decreased over time, which is great. So in the first study, we'll see that about 2.5 times more females are in the lower class compared to that of males. But in the second study, about 1.8 times more females end up in the lower class, which is, it's decreasing, but it's still there. We'll also note that the power of college in enabling mobility to a higher class has also dropped. And you can see that right here in that about 77%, 75% of students who just attained a college degree in the lower and middle classes ended up at least in the middle class, but that's dropped to less than 70%, to about 64% in the latter study. So what does this mean? So we note that socioeconomic background is a much more significant factor in the 2008 to 2018 study compared to that of 1993 to 2003. So in each study, we note that there are top 5 factors that kind of predicted whether or not an individual's socioeconomic status would end up in lower, middle, or upper class. Those highlighted in yellow are indicators of socioeconomic backgrounds. And what we see is that in the first study, it appears that college is the great equalizer and that just having a college degree enables individuals to dictate their own future. So socioeconomic status wasn't as big of a factor. But in the latter study, we can see that it appears to be a much bigger factor, but we also have to note that our models only obtained the highest accuracy of 50%. And what this means is that there are additional factors to consider, and that includes that college is getting more expensive. Just year over year, adjusted for inflation, the cost of attending college has increased 26%. Another factor to consider is that more people are going to college. In fact, 38% more people are actually attending college, which might lead to the need for more relevant degrees. So just having a college degree isn't sufficient anymore. It actually has to be relevant to what you want to study. So the next question that we want to explore is how aligned are an individual's initial expectations and their educational attainment 10 years later? And here, educational attainment means their target degree, whether or not they wanted a master's or a PhD, etc. What we find here is that there appears to be a better alignment of expectations and target degree attained as socioeconomic status increases. So off to the right, you can see that the proportion of individuals who fail to achieve the degree they expected to almost follows a linear fashion, and that those from the upper class better attain their expected degree compared to that of middle and then compared to that of lower. So the hypothesis here is that the power of cultural capital is really strong, and that those from higher classes are better equipped to know how to achieve goals and what it takes, and even to know what their initial options were in the first place. Now, the same trend happens when we look at whether or not an individual is dissatisfied with their undergrad majors over time. So first off, just regardless of the major that you picked, 10 years down the line, everyone was dissatisfied with their choice of undergrad major. But another thing to note is that particularly for those who majored in arts and humanities, social sciences, and health, we can see that that discrepancy is there again, that those from upper class are much more satisfied with their choice of undergrad major compared to that of middle and again to that of lower. So we'll see that the alignment between expectations and attainment of target degree seems to have become less dependent on socioeconomic status over time. And we can see that that's probably because in the former decade, there wasn't the internet, that people were much more reliant on their immediate network, and this included their parents. So instead of having all of these third-party sources to search for, you could only rely on what your parents told you to dictate your future. Alternatively, that's not the case in the latter study. With the proliferation of the internet, you didn't have to rely on just your parents. You could search for third-party opinions and experiences on what you can pursue and achieve later down the line. So the conclusion here is that the impact of socioeconomic status of origin is clear, but it's dwindling, so that's good. But recurring themes include generational differences and cultural capital. There are also a million other considerations that we can take into account in this, and that includes impacts on women. There is evidence that they face other ceilings other than just their socioeconomic background, such as expectations to be a homemaker, just the gender wage gap in general, etc. I touched on this earlier, but there's also the relevance of the college degree. Just having a degree is no longer sufficient. There's also the issue of quantifying occupational prestige. Occupations aren't just based on their monetary value to an individual? How prestigious is it? That's what we want to define next, and that will be the next step for this research. And also motivation and internal factors of individuals. People are more than just a data point, and can we more accurately quantify how a person gets motivated? There's also an additional caveat that those in the 2008 study graduated during the Great Recession, and that's not a factor that we took into account in this research. That also warrants more investigation. So in conclusion, the issue is complicated and is changing over time, because considerations these days now also include the proliferation of social media, increase in political polarization in the United States, and the spread and acceptance of misinformation. But a common theme across generations is the impact of cultural capital, which warrants much more investigation and research, which it also provides the next step for this research. The goal here is, if we can better quantify the impact of cultural capital, we may be better able to inform policies that help mitigate the impact of socioeconomic status. Thank you.